Welcome to the Sabre RD online training course. This series of fast-paced videos will quickly teach you the full power of the Sabre RD simulation environment. In this section, we look at time domain analysis. Time domain analysis is a simulation that mimics powering up a circuit and exercising it for a set amount of time. It is the most common operation in the Sabre RD environment. Time domain analysis is also called transient analysis. Let's perform a time domain analysis to get a feel for Sabre RD. We start with a simple RLC circuit that has already been schematically captured. We select the Simulation tab and choose Transient Simulation from the pull-down list. The required fields for this simulation are the end time, which we set to 10 milliseconds, and the initial time step, which we set to 10 microseconds. To initiate the simulation, we press the green arrow button. There's a simulation progress bar to the right of the button. During the simulation, waveforms of some of the circuit's variables are saved. The variables in the plot file are listed along the left-hand side. Double-clicking the output node voltage displays its plot in a separate window. As expected, the plot ends at 10 milliseconds, corresponding to our original setting. By default, only node voltages are saved in the plot file. Later, you will see that this can be changed to include more waveforms by accessing the Advanced Simulation settings. There are a number of operations we can perform on the waveform. Under the Analyze tab, we select Apply Measures. By selecting the measurement pull-down and going to the Time Domain submenu, we can see that there are a variety of measurements we can perform. For this waveform, a rise time measurement seems appropriate. Upon selection, the measurement is shown directly on the plot. Before we go further, let's first look closer at number notation in Sabre RD. Notice that we specified the engineering notation of 10M to represent 10 milliseconds for the end time of the analysis. We could have also used 0.01 or specified this parameter with an exponent. All three of these notations are equivalent and acceptable. However, a space between the number and the suffix is not allowed, nor can the units be included. Both of these will result in an error. Here is a list of engineering notation suffixes that Sabre RD understands. Engineering notation is accepted throughout Sabre RD. Notice that it was used on this schematic for the component values. Let's revisit the time step specification. Sabre RD uses a variable time step algorithm, adjusting it throughout the time domain analysis. However, you need to specify the initial time step that will be deployed at the beginning of the simulation. In most cases, setting time step to time end divided by 1000 should work well. For circuits with rapid switching, a time step of 1 nanosecond is a good choice. Let's explore further what happens after we launch the transient analysis. We can do this by looking at the netlist and simulator transcript windows. They list out more explicit information about the analysis. First, we select the Netlist Transcript tab. This shows what happens as Sabre RD reads the schematic and produces a netlist that is readable by the simulator. If there was a problem with the schematic, the process would have stopped and an error message would have shown up here. We select the Simulator Transcript tab. After the netlist was successfully created, it was read into the simulator with this command. We see a line that lists two commands separated by a semicolon. The first is a DC analysis. This establishes a starting operating point at time equals 0 for the start of the transient analysis. DC analysis is discussed in more detail in a different section of this training course. The second is the transient analysis command itself. It is good to become familiar with these transcript windows because it can help you troubleshoot errors if they occur. For each simulation command, only a minimal set of parameters are shown. However, on the right side of this tab is a small icon that lets you see the Advanced Simulation Settings dialog window. There is a tab along the left side of this window for each of the different simulations. The advanced settings for transient analysis are divided into several sections. When you click on the names of any of the settings, a short description is listed on the bottom. Adjusting these parameters can help you limit the amount of data collected, save simulation time, improve accuracy, and more closely monitor lengthy simulations. They are described in detail in the Sabre RD user manual. Two of the advanced settings determine which signals are available for display after a simulation. These controls are helpful when simulating larger designs with many signals. By default, only across variables are displayed. For electrical circuits, the across variables are typically node voltages. You can also choose to display through variables. These are currents flowing through the pins of the components. These currents are listed hierarchically in the plot file signal list. Another advanced setting is used to more precisely control signals for display. By default, all top-level signals are displayed. You can choose to display all signals regardless of where they exist in the hierarchy. Or you can choose individual levels of hierarchy. You can also choose individual signals. Note that you must adjust these settings before executing the simulation. This concludes this section of the SaberRD online training course. To download a free student version of SaberRD, go to the Synopsys website. To further your understanding of this material, go through the lab exercises found at the link listed in the description of this video.